Hey everyone, welcome back to the Calculus Chapter 10 practice test, and today we're going to be checking convergence for this series. So we're meant to find the interval of convergence for the series that we have here, and like every convergence interval of convergence, I think the first thing you should do is take a look at the series and make sure that you're not looking at a geometric series. Of course, there's a factorial here, so I don't think this is very geometric. Regardless, let's check out the first four terms. Do a little multiplication. And if you're still not convinced, go ahead and simplify those factorials. And yes, 0 factorial is equal to 1. And yeah, I don't think anyone's going to confuse that for a geometric series. There's no one number that we're multiplying to get that series on the denominator. Well, now that you have a series that's not geometric, you know that the first tool that you're going to take out is going to be the ratio test. And with a power series, we're going to set our ratio less than 1. Of course, I like to multiply by the reciprocal of the general term. And so you know what we're doing here. We're trying to set the limit of the ratio test to be less than 1, so that when we solve for x, we're going to create values of x for which this series is going to converge. Because when the limit of the ratio is less than 1, the series converges absolutely. So we're going to go ahead and put the general term, the n plus 1th term. First I write the nth term, and then I replace all the n's with n plus 1. Be very careful on that denominator because there's some algebra problems that could happen if you're not putting the n plus 1 in parentheses. And then we multiply that with the reciprocal of the general term. To simplify, I'm going to take that x minus 3 to the n plus 1 power and expand that to be x minus 3 to the n multiplied by x minus 3. We're going to practice good algebra on the denominator. And then we're going to expand that factorial on the denominator just a little bit. I know I can stop when the factorials match. And then now here's the fun part. We're going to do some canceling. Now I notice that the numerator has an x minus 3. And of course, x minus 3 doesn't have a n with it. So I can take it out of the limit. And in this case, we're going to have to change the numerator into 1. Now remember, I have to keep that x minus 3 in absolute values because I don't know what the value of x is going to be. So it still needs, x minus 3 still needs to be a positive expression. Now let's take a look at the limit. I can see that the numerator is constant and the denominator is polynomial in nature. So it's going to keep on growing as n grows. And when you have the limit of an expression where the numerator is constant and the denominator grows without bound, that limit is 0, which means the limit of the ratio is equal to 0. So it doesn't matter what the value of x is, the limit of the ratio is always 0, which is always less than 1. So since the limit of the ratio equals 0, and 0 is always less than 1. So the series of a converges for x between negative infinity to positive infinity, which is to say that the series of x minus 3 to the n over 3 factorial converges for x between negative infinity to positive infinity. And if you're feeling fancy, you can say x is an element of the real numbers, which is that double R looking symbol that you sometimes see. It's the same thing as negative infinity to positive infinity. And there it is. our interval of convergence for the series. Have a good one, and we'll see you in the next video.